So hi everyone, I'm Razvan and Andrei. We're from the Unikraft project. We're a bit of outsiders here, as I said a bunch. We've been part of we started actually as a Zen project. This was in 2018, 2019, I think. And we've been giving talks, and we've recently, with the assistance from Kelly, tried to get me more in the community. We're going to also give you some insights of what we've been doing with respect to Zen, as we've made progress towards getting this as a better platform with Unikraft. Okay, so getting started, our focus is going to be on Unikraft, the Unicorn technology, also an open source project, and how we've been using it for a cloud use case. There is also an embedded use case. For example, Stefano knows a bit about that because he's been advising us about it, but the focus is mostly here on doing cloud deployments. There's a startup company that spun out of the Unikraft community project research item. And what we've been doing is we've been making progress towards making Unicorn technology as a technology you want to go for cloud deployments. And based on that, we've been doing a lot of ping-pongs with potential users on their pain points. And here, for example, are some items that people talk about. So when they have to talk about use cases, they feel squeezed by my current clouds without much innovation. Something else, what I begin, there's always too much to back. So a lot of clutter, a lot of items that have been added to a lot of cloud deployments, and you want to make those, I'm sure, easier, less costly, easy to use. It says here, needlessly complicated. So things that are buggy, painful to use, difficult interfaces, you go to a lot of steps, you get minutes, configuration, startup times, a lot of items, something like this. Other people are complaining about their billing costs. They want to have accurate bills here, and hey, I'm running this much, I want to pay this much. They worry about cold start times. It takes quite a lot to start a new VM, to start a container. You want to make that even faster. How can you do that? Also cold boots, as I told earlier, data privacy, cold start times. So this is kind of a recurring thought. And while we're discussing, as I say, hey, unikernels really do fit this concept of reducing the the cold boot times, as you're going to see soon. Also, this is something I picked up last week from the CNCF forum about wishes, and yeah, I wish to understand Kubernetes. Okay, let's make that four rules. It's a beast. We get a lot of people that, hey, I want to have Kubernetes integration, and we feel there's this mixed feeling about it. We understand it's kind of a standard for cloud deployments. However, it's also a huge beast to deal with, and it also adds levels of overhead to it. And that's why we kind of have this rough relationship with it. And on the positive side, this was something we got from a user and said, I came across Unikraft a while ago and said, oh, that's cool. And he saw the cloud offerings, and he was excited to try things out, and we are on that. Now, for this, I'm going to do a bit of overview of what Unikraft is about as, well, virtual machines, hypervisors and everything. How do containers handle that, and what spot they would fit in the whole cloud ecosystem? And for starters, the goal of this is to focus on applications, right? So we want to get applications running. And just to show you this, I'm going to do a short demo of how this currently works on our Unikraft-based cloud platform. So we're going to try a WordPress deployment together with, based on a MariaDB. We're going to use Docker, but not for running, but only for building. We'll talk more about that. And we're going to use Unikraft and Kraft Cloud, our platform, for this. So that being said, let me just quickly jump to this. I have the commands here because I want to make this as quickly as possible. What I do now, let me maybe just do a clear screen. This is a command that's going to start a MariaDB instance. Once this is running on Unikraft, so I have this instance. I run this command, and there it is. Boot time, there's also something I can do. I can use something like Kraft Cloud instance logs for this instance, and it can tell me about boot time. So it booted an entire MariaDB instance in 150 milliseconds. This is quite large, actually. If you were to go Nginx, you would go 10, 20 milliseconds. But yeah, you have a database. This is a fairly large image. Then what we do is we start this can be simplified if you have a config file. What you do here is you're going to start a WordPress instance, right? You get the URL for it. If I'm going to venture here, I'm not going to spend much time into that because I don't want to waste a lot of time. But if we do here, we're going to quickly create. Let me see if I'm able to do it very quickly. Yeah, I'm doing shameless marketing here. Sorry for that. Okay. Let me do a test. Okay. So this is going to install WordPress, and then when I'm going to log in, I'm going to use Unikraft and Unikraft. Sorry. Okay, so this is installed. This is running on our cloud, Unikraft technology. If you go to here, this is already installed. So it was only a couple of commands running very quickly, starting really fast. You were able to get this going. And this is something we want the cloud to be. Something where you just run some commands, you make a few clicks, and it just works without spending a lot of time going through all the different layers or trying to do a lot of buttons and configurations to make this happen. Something else on this is another item we have, Tyke. Tyke is, no, sorry, it's the other one. Tyke is a gateway API. I'm not going to run this. I'm going to ask you to trust me not to spend more time on this. What we have here is, if you check this out, there are two instances. One of these is a Redis one. It booted in 20 milliseconds. So this is what we're actually talking about. Another one is the Tyke one. It booted in 50 milliseconds, right? And what they do is, if you look here at some point, we're going to do this curl. And yeah, I removed everything. I removed the instances. I removed the Redis and Tyke. And you were able to query it. It was behind the scenes using a Redis instance. If you are familiar with Compose, with Docker Compose, this is similar to what's happening here. You create a network connection between those two, and you are able to use them as such. And anyone who wants to deploy any sort of cloud-based application or service should be able to do this. So this is the, let's say, the dream. Simplifying, debloating the cloud, making it as efficient, as effective for your use case as possible. So this is the demo, and basically what you're going to be concerned at is application. You have an application that you want to run cloud native. It can be a website, it can be a database, it can be any sort of service that provides you with an endpoint. It can actually be a batch service. You're going to run LLMs, whatever you want. And you want to go through those steps. Build, package, push, pull, unpack, run. This is something you want to do. And you want this to be seamless, efficient, cost-saving. You don't want to spend a lot of time on it. You want a lot of people can actually throw money at it. We don't want you to throw money at it. We want you to actually make it cost-effective. And what are your solutions to this? So typically, you are going to have either a choice between using a virtual machine or a container, or, as most likely is the case, both of them. And we want them to run everywhere. You don't want dependencies, and you want isolation. And VMs, for this matter, as you may know, have good isolation, good resource control, but there is an overhead attached to them, and there's difficult to create recipes. Whereas, for example, containers, you have recipes in Docker files, where you state everything, where in Docker Compose files, everything easy to specify. You just grab that, and it simply works. You have registries, you have a lot of tooling on it, you have good performance. There are, of course, isolation issues, which is why if you're going to go to a lot of vendors, cloud-based vendors, what they do, they pre-provision VMs, and inside of them, they run containers. Kind of this weird ecosystem where the upside of containers are, let's say, removed by the use of virtual machines. What we want to do is have best of both worlds. So we want isolation, we want recipes, we want riches, we want it all, right? So everything that's available, we want to make it happen. And we feel, where we think, where we provide, we market that Unikraft is that solution. So the Unikraft technology, open source technology, is going to be useful for this because it's a virtual machine. It has recipes. We're going to see about that. It uses a registry. We have the images there. What you just saw when I run that command, it pulled images from the registry. They are packed as OCI, Open Container Initiative, so your classical container images. And there's very good performance, and you have cloud computing down right without the added clutter. How is this achieved? Note that Unikraft is a unikernel. So this is kind of a totally different approach to things. You don't have the classical user space kernel mode separation. Everything is running in the same address space. And on top of that, we have what we call extreme specialization. This is an OS that has been written from grounds up, from scratch. So there's no Linux. There are some BSD bits because of the compatible licensing, but it has been written from scratch with the whole idea in mind that if you have a specific use case in mind, you should be able to customize your build, your application, and your configs inside your application for that build. This makes it a bit difficult to find the proper balance and the proper config, but once you do that, you're going to be fairly certain this is the uttermost performance you're going to get. Whereas even if you're going to try Linux and try to modularize it, there are still a lot of items that are going to be left there. So that's affecting memory consumption, attack surface, and also latency and overhead. And let's take a look at how this is going. How we did this. We're going to take a peek in the internals of things. We're going to show you then a quick demo on how things happen, and then Andrei is going to highlight what we've been doing recently with support to Zen. Note that what you saw as the cloud-based deployment, these are currently happening because, well, this is a lot of people are using, are based on KVM. So this is the default one. But yeah, we're making progress in reruns on Zen, and hopefully if there are people that have Zen-based cloud deployments, they would be able to integrate it in their services. Okay, so what we actually do here, and I mentioned Docker, and people say, okay, is it a container? Is it a virtual machine? What is it? Well, we actually use Docker because we think Docker is awesome, but not for running. It's awesome for building, but the runtime itself is a VM runtime. So if you want to run on Zen, KVM, VMware Hyper-V, you're going to run it with. But the build phase is going to still happen with Docker, meaning we're going to use Docker files for this. You're going to see soon. Then we're going to run this with Unikraft, so inside the VM on top of a hypervisor. And then this is going to be deployed on a Kraft Cloud instance. And everything is going to be facilitated by our, let's say, tooling operations tool we call CraftKit. Everything is happening there. What we just saw, if you recall when I did the commands here, I used Kraft Cloud. You're going to see our commands on Kraft build, Kraft run as we demo them soon. So what's actually then happening here? I mentioned about Docker. So, sorry. You have a Docker file. This is your spec. The output of the Docker file, everyone's going to, yeah, I'm going to run something. No, the Docker file is used for you to build a root file system. So what we do is we use BuildKit. There's an alternative, it's called Builda. This is some part of the Docker ecosystem. And out of it, you get the application file system, because that's what you want. Note, it doesn't contain any sort of kernel or runtime. So typically, you have the application file system, and then you use Docker run on it to run it on your Linux containerized environment. No, we don't do that. We just grab the application file system. And this is typically Linux binaries, language source code file, Node.js, Python, whatever configuration files. On the other side, we have a Kraft file. This is our own, let's say, spec. And this is mostly used for runtime info. What this does, this is going to build the runtime itself. It's going to build the kernel. So this builds the kernel. We call it a runtime because it may include some items that relate to the language environment. For example, if you're using Rust or Node or Go, whatever, you're going to include those just to make the application-centric part in the application file system, and this is going to be the runtime. So the kernel itself and potentially, but not mandatory, the base language or application, and also potentially Linux binary files. So we're trying to use as much of the existing ecosystem as possible, but until the runtime. When the runtime comes about, this is going to be isolated inside the virtual machine using a unikernel technology. What's going to happen then afterwards? You have the file system, you have the runtime. This is typical for, say, anyone who's doing embedded development, right? You have the kernel, you have the file system, you have some sort of initRD. I'm not sure if you're using Yocto or something, you basically have these two items. We have a packaging system, and then you get the OCI image, meaning that you're going to have something very similar that people use on Docker. And this can be then set into a Docker registry. Ideally, in the next future, you can do something like Docker Hub or something. We have our own registry, but that means that tooling-wise, If you're a person working on cloud on ops or DevOps environment, this is going to be seamless too. It's like that. It's just like using containers, but except that when running them, when deploying them, you're going to use VMs, unikernels. And I talked a bit about all those Linux items here. And yeah, you're using Linux, yeah, because it's a pain. It's actually very, very difficult for people to port new things to new OSs, right? No one is going to do that in the right mind. I mean, it was Jake that told earlier about people not caring about stuff. They just want to work. Yeah, of course. I have this application. I have Nginx, MySQL, Node, whatever. It works on Linux. I want it to run here. And what we did here is we have something that we call POSIX compatibility layer. We call it short bin compat, binary compatibility. We are going in the Unikraft community, the term bin compat refers to this. How does this work? Imagine you have your typical Linux self. This makes a call to your C library, and this makes a system call. What we do here is, typically this is a trap. You then do a domain switch from user mode to kernel mode. There's no domain switch here. Everything is running in kernel mode. This is a unikernel application. But there's a trap interface that we simulate here, and this ends up in something that we call component syscall shim. And this syscall shim is able to redirect to the actual implementation of that syscall that we provide. So basically, we provide our own syscall implementation for most of the syscalls that are available on Linux. It's not all of them, because most of them are not used, but yeah, every time there's a bit of an addition, so clone 3, there was some sort of items, yeah, we had to add those there as well to provide this similar interface. This is the library that implements it inside Unikraft. And also we have support libraries, in this case, the networking library. LWIP is a good one, but it's pretty slow. So there are better variants, but this is the default one we're using now. And this gets called here. This is your basic network stack implementation. There can be others that you select, you specialize from your use case, and this gets stuff done, right? So, and this is happening with Unikraft. I said this is a open source project. It has 7 years now. It's close to be here. Which has been going fairly well. We are actually part of release 0.17, and you also you hit the nail on the head when about testing. We actually found some screw-ups I did last night at 2 a.m. When merging some stuff, and we are now trying to, it's hardware randomization stuff that we are now trying to fix. Yeah, testing is a beast. You're always going to miss something. This is our part, so it's been a growing community. We are now close to 2.4K GitHub stars, a very healthy Discord community. Today is going to be the release, hopefully. The commits we have a good commit ratio. The number of lines of code has decreased because the project itself has now become more matured, and a lot of items are mostly now doing refactoring and improvements. We're talking about now about security, re-architecting, refactoring, so a lot of work is now being placed on making this work properly. It's our start history, and as I said, everything, the glue that keeps all of this together is the tooling. So apart from the kernel itself, we have CraftKit, we call it companion tool, that's able to configure, build, set up, run, build, configure, package, pull, push, all those items, all the ops that you require with your typical deployment, now is handled by CraftKit. And yeah, it has this integration that are put into place to make this happen with everything. And the platform itself is Craft Cloud. This is based on Unikraft technology to allow you to be able to actually benefit from what we think is a sane, healthy, thin, as it's supposed to be cloud ecosystem. This is the application support. A lot of things have been happening. It's now close to instant to get an application going because of the amount of support that's been happening. And you also saw MariaDB, you saw Tyke, you saw WordPress, Nginx because of WordPress. I'm going to demo together with Andrei several others now. And you can just check the open source ecosystem for this info. What I'm going to do now is I'm going to do a short demo, and then Andrei is going to pass it on. So I'm going to focus just very quickly on KVM, and then I'm going to give it to Andrei to tell you more about what we've been doing with support from the Zen for the hypervisor. We're also going to host a design session on Thursday, right? We're going to work on these items together and make progress on them. So just to give you a glimpse, This is a very quick run, so what I have here, I'm going to once again ask it, I'm not going to spend time building it. What we did here is we built with Craft build on QEMU R64. QEMU is KVM, let's say QEMU and KVM. Because you also have Firecracker, that's why it's called QEMU. You get the image here, and then this image, this one is your typical kernel. It has everything. So you have this image which is 230K large, and this is the one that stores everything. And then if you're going to do something like craft run, it's simply going to run it, right? So this is your local run of the entire kernel. Everything is going to run like this. Something a bit more interesting is we're going to go here. This is an HTTP server. If I were to go here, it's a very simple one. I implemented it. It just gives you a hello world reply. So, sorry, what the? Yeah, it was caps lock. This I already built. Then if I use this command, I'm going to start it on port 8080. It does this wrap up here. It listens on that port, and then if I want to test it, I'm just going to curl it, and it's giving me hello world, right? Everything here also, it's on, you have the 4047K image with the entire server. Everything is here. So the file system, the kernel itself, all of the items are part of this. And finally, maybe the nicer one is the Nginx one. So let me just look at the size. This is Nginx happening here. This is larger because, yeah, it's 2 megabytes, but it boots really fast. You can get it, I think, to 10, 15 milliseconds. That's why we call it the millisecond platform. And if I'm going to run it like this, the interface is very similar to Docker run, except that it's running as a virtual machine. And now it started. And if I'm going to go here, oh, sorry. Yeah, you get the Nginx output from it. I'm going to leave it to Andrei to give you a bit more about the Zen. Yeah. So
this one works, yeah. Okay, so hi everyone. My name is Andrei, and I've been working for the past few months on the Zen platform on the compatibility with Unikraft. So what we've been seeing here with the Docker integration and all the OCA images, these were not really available for our Zen support, essentially because we've been lagging a bit behind with it, and the two main parts that we need to essentially work on are the tooling and the binary compatibility layer for Zen. So in the past 6 months, we've been working on the tooling. We've almost merged it. It's almost upstream, but the binary compatibility part is still a work in progress. And there we are essentially looking for PVH support for Zen. Now, at the moment, we've been only, okay. Yeah. So at the moment, we are only supporting PV mode on Zen. So, which one? Windows chassis. Okay, yeah. So here we have basically what Razvan has also shown you with KVM, and but now we are just running it on Zen. So yeah, so essentially the same things, just running on Zen, the hello world. Now going forward with some networking support, we have a bridge here. Yeah, weird microphone setup. So actually looking at the networks made. So here, just a second. Yeah, just a second.
What's happened when you do a duo demo? Yes.
Yeah. So does it sound right? Okay. So now using CraftKit, we've made some bridges. And we want to use these bridges, I mean, one of the bridges to actually communicate with the VM. So we're just going to spawn it, choosing the Zen Summit net. providing an IP, just I don't know, 23, and this should just work. Now we can curl it. And now we have this simple GET request sent. Going forward, we also have the Nginx platform. We are using the 9PFS transport in this for Nginx to actually supply a volume to it. So just as you are probably accustomed to Docker, you can pass a volume with Kraft. So we are from the network. Just like this, and getting the root file system, mounting it, running it, and now essentially curling it again. We have the actual response. So,
You did cat.
oh yeah, cat.
And do a dot one at the end.
Yeah. So yeah, it's the different one. So this part of so running it is essentially easy. Now, these are simple applications that have been basically cross-compiled with Unikraft, with the kernel itself. This is undesirable in a bigger context. So essentially what we want to have is the part that Razvan has shown before with Docker. So tooling and binary compatibility are two ways to accomplish that. So we need both of these worlds to merge together and provide us with that simple interface. Now, as I've said, PVH support is on the way, hopefully soon, and the tooling part is almost there.
And the ARM64 part?
Yeah, so now going forward, we also have we've had a community contribution by Alexei from EBAM Systems that has brought ARM64 support to Unikraft. And
This is also because of the embedded target. There are also ARM64 CPUs in the cloud environment. You have Graviton, and now there's the idea with, what was it, from Ampere. So we're also looking into that.
yeah, so
This is a board we have from NXP. We have
yeah, this is a small board, and this doesn't run the GraphKit CLI tool, so we are just going to use the libxl standard tooling from Zen. So just have here a simple, basically the same app, just a simple configuration that you all know and love. And let's see if, okay, Excel create.
We are actually, that system is 3 links away. We SSH into a proxy, and then the server, and then the board. So it's 3 SSH connections, one on top of each other.
Many proxy jumps. So essentially the same thing, just curling it. Yeah, the file exists, so.
So this is an ARM64 board that we installed Zen on it. What version is it? Zen 4 something, if I recall?
So this is Zen 4.18, yeah, and both on the x86 and ARM64.
Right. So yeah, I think that's it.
Yeah.
Okay. So just as some closing remarks, this was the demo from our side, and sorry for this. This is you get Unikraft working as a summary of the items. We have feel this as a proper way of doing cloud deployments. I mean, there are other use cases embedded in the others, but we have this nice sweet spot between using VMs and using containers to all these benefits. If you're interested about this, check this out. So we're also very happy to be part of the Zen community and bridge the gap between the two of them, make sure we have proper Zen support. We're looking for others here. And if there are any particular use cases we're fond of, we talked also with Maria about using, there's a particular use case that we've talked about on Matrix for using Unikraft. So we're looking for any items you feel interested in. And as a note, we're going to organize a summer workshop. It's going to be an online one in July. So if anyone wants to join, it's going to be full online, going into Unikraft technology, cloud deployments, and nice open source project to work on. And these are some links that you can look into. That would be it. Thank you so much. I'm not sure if there's any time for questions or any items. Yeah, please. This is what Maria is actually working on. We had this. I don't have the full details. We had the discussion started on Matrix. There are some particular. I'm not sure, builds, runs, or something where you want to run Chemo, and we are working towards that, yes. I mean, anything that's running on Linux should be running on Unikraft. What we don't have yet is what we call multi-app support. Because everything is running in the same address space, having multi-process is a bit of a hackle. We've worked on that. We basically use different parts in the address space for different processes. That's going to be a bit of a difficult, and that may be also a security issue, but it kind of depends heavily on the use case. But apart from that, anything that's running on Linux should be available to run on Unikraft. Yeah, please.
For these examples in the demo, how much memory do you have to use maybe?
For example, for the Nginx one, 8 megabytes. So the actual Nginx running a web server, it can be 8 megabytes. So yeah, that's, I mean, cold boots, low memory resources, that's what's actually happening. What let's say the most important issues we've been facing with potential users is on friction. That's why we want to have this Docker integration CraftKit, making everything seamless. People they don't care about the underlying thing, they just want to reap the benefits, and I fully support that. And we've been making very good progress towards this, but nobody cares about unikernels, user mode, kernel mode, yeah, syscalls, no, we don't care about it. I mean, we're geeks, so we care about those, but people, they just want to use them. And we've been making progress towards that, and we are continuously trying to remove friction just for this. Yeah?
So you have your Craft Cloud.
Mm-hmm.
Can people create their own little in-house?
For sure. Yes, yes. So there are, I mean, if you use Craft Run, you're going to do it yourself. Actually, it's a bit interesting. We don't use Craft Run in our own deployment because I'm not sure. There were some, at some point, Craft didn't have all the features. But if you want to have your own cloud or some sort of setup, you just grab the open source part, you use Craft build, Craft deploy, and Craft Run, that's going to be it. For the platform itself, there are some proprietary features that are out there. Yeah. We want to make money after all, but most of the features that you would want to run should be available for your own use cases. Yes. Was there someone else? Yeah.
One of the main things that you're bragging about here is the speed of time, the boot time. Really
Yes. Yes.
But is that something you find users actually? Is that a pain point for?
Yes. Yes. So as I showed you at the very beginning, if you check here. Cold start times, overhead, cold boot time, cold start times. So it's a problem. I mean, it's very interesting because at some point we were very keen on making this Unikraft. It's awesome. You can grab the image and use it yourself. Problem was it was really fast, but then all the extra clutter was added to that. So that benefit amounted to close to nothing in the overall run because there are those layers, and that's why the idea was to create a platform that's going to be basically removing all that clutter to actually reap the benefits of this. Because so it boots really fast for sure, but you also have to have all those extra layers of proxying, redirection, image loading, whatever, well put into place, because otherwise you're going to have 0.1 millisecond increase, but if the whole thing is 10 seconds, it amounts to nothing. But if the whole thing was half a second, then 0.1 means 20%, so that's a lot. Yeah?
How much of an overhead, for the Zen version, how much are you bottlenecked on Zen tool stack and other?
I think Andrei should answer that.
Yeah, I think this one should work.
Yeah.
Okay, so are you talking about the tooling part or so?
Well, no, I meant when it comes time to start a
Okay.
unikernel,
Yeah.
how much is the overhead of Zen and its corresponding
Oh.
code? Like, for instance, of setting up Zen store and things like that, compared to the actual unikernel boot time, and compared to, say,
So
KVM.
I don't have the measurements of that. I should probably do that, but I don't think, it depends on how many drivers do you actually register and.
So I want to jump in. The initial, it was a research paper. It was in 2017. It was called Light VM. My VM is faster than your containers. This was actually started on Zen. And I had a colleague, Costin Lupu, they worked on that, and they scrapped everything from Zen. They ditched Zen store, redesigned a lot of items just to make it boot in milliseconds time. That was the POC. That proved that this could be achieved. So this requires, if you add all the drivers and all the extra clutter for Zen, that may affect you. You want to minimize it to the least what you can. For example, on KVM, there are two VMMs. I mean, there are more VMMs, but there are two VMMs we are using. One of them is Kimu, and the other one is Firecracker from Amazon. And Firecracker is the one that's able to get you, and we're using Firecracker here, those milliseconds times. For example, for Nginx, I can get, let's say, 10 milliseconds with Firecracker. It's going to be 30 or 40 milliseconds with Kimu because of all the driver it initializes. So this mostly is not the hypervisor itself that's the problem with KVM or Zen. It's what the added extra layers that can be part of it. I don't have the exact details of what Excel does behind the scenes, but that's what you need to craft.
Okay.
Once that is enabled, it should be fairly okay.
So you need an alternate. So basically, to make the Zen stuff fast, you need an alternate tool stack.
I couldn't answer, but if not an alternate, you need a finely tuned tool stack for it, for sure. This is what Firecracker is doing with KVM.
If you want Firecracker numbers, yeah, probably.
Okay.
Yeah, Kelly?
I've got a question about
Yeah.
So did you use KF/X for something with Zen, and what were the results?
KF/X?
Yeah.
Yeah, so this, I think I know what this is about. Costin Lupu, he was our colleague. He was a main contributor. KFX, if I recall, is for kernel fuzzer with Zen. I may be wrong, but I think that's it. And he did this work for a project he was involved in related to VM cloning. So he was able to use some sort of fork-like mechanism for unikernels to be able to do that. And he was using KFX, but not to find bugs. He was using it as a measure of how fast you could do fuzzing when using VM cloning. So I'm not sure if that answers your question, but that was the idea there. We are actually looking, because of the security part, we are looking into doing some level of fuzzing. That's going to be, there are different approaches there. KFX may be one of those, but in that particular paper, this was mainly used just to highlight how using VM cloning can be an obvious way of speeding up fuzzing of VMs. His idea was VM cloning. Right. Okay, thank you so much.